We have here 4 cycles, and we are trying to solve for or show the equivalent permutation of their product, and we are on S8. Now these cycles are actually identified as cycles because we could see that in specific permutations involving this, the rest of other elements are just mapped to themselves, or yeah, the orbits containing them, or the orbits have exactly one element with them. I'm talking about, say for example here, 1 and 2. This would mean that since this is a cycle as mentioned here, that would mean that in the specific permutation in S8, 1 is mapped to 2 and 2 is mapped to 1. Where are the rest of the numbers? 3, 4, 5, 6, 7, and 8. They are just mapped to themselves, such that we only have at most one, or exactly one orbit containing more than one element. That means 1 and 2, and that makes this a cycle itself. For 4, 7, and 8, so 4 is mapped to 7, 7 is mapped to 4, and 7 is mapped to 8, and 8 is mapped to 4. All of the rest of the elements on this specific permutation where this cycle was taken to are mapped to themselves. Now here, I'm going to show you the two different methods. The first method is what we consider is a longer method, because you would see later why it's very long. Okay, but this is of course the idea of coming up with equivalent permutations on each of the given cycle here. And with that, we're going to, instead of multiplying cycles, we are to multiply permutations. And of course, later, as mentioned, we will have longer steps. But of course, we have a shorter method, but this method will allow us to really analyze just simply using these cycles. So first, the longer method. All of these are under S8, so we expect that the permutations are also in S8. Hopefully my space here are enough. So you have here 1, 2, 3, 4, 5, 6, 7, 8. I don't think it's enough, but let me try. 1, 2, 3, 4, 5, 6, 7, 8. Almost there. 1, 2, 3, 4, 5, 6, 7, 8. Because we have 4 cycles, that means we also have 4 different permutations. 1, 2, 3, 4, 5, 6, 7, 8. As I told you, the spaces are not enough. But anyway, let's just try to use that. And of course, I believe you already understood that idea there. So for the first cycle, 1 and 2, as mentioned, 1 is mapped to 2 and 2 is mapped to 1. The rest are just mapped to the respective selves. Okay, such that if we come up with a cycle later, we only have 1, or orbit of 1 and 2. That's the orbit containing more than one element, and the rest would be unit sets. Okay. How about the second? We have here 4 is mapped to 7, 7 is mapped to 8, and 8 is mapped to 4. The rest, 1, 2, 3, 5, and 6. For the next one here, 2 and 1. That's very obvious, similar to this one here. So 2 is mapped to 1, 1 is mapped to 2, and you have here 3, 4, 5, 6, 7, and 8 as well. And for the last, it's a bit even longer here. 1 is mapped to 5. Then 5 is mapped to 7. Hopefully we could see this clearly. Then we have 2 is mapped to 8. Okay? 7 is mapped to 2. 8 is mapped to 1. Again, 8 to 1, 7 to 2, 5 to 7, 2 to 8, 1 to 5. Okay, and the rest, you have 3, 4, and 6 here. So we can solve for the permutation as we multiply all of these permutations here. Of course, the result is 1, 2, 3, 4, 5, 6, 7, and 8. Still a permutation in S8. Let's start. 1 is mapped to 5. Then 5 is mapped to 5. Then 5 is mapped to 5. And then 5 is mapped to 5. Okay. Next, how about 2? 2 is mapped to 8. 8 is mapped to 8. 8 is mapped to 4. And 4 is mapped to 4. Okay. Next, 3 is mapped to 3. 3 is mapped to 3. 3 is mapped to 3. And of course, 3 is still mapped to 3. How about 4? 4 is mapped to 4. 4 is mapped to 4. 4 is mapped to 7. And 7 is mapped to 7. Next is 5 is mapped to 7. 7 is mapped to 7. 7 is mapped to 8. And 8 is mapped to 8. 6 here is mapped to 6. 6 is mapped to 6. 6 is mapped to 6. 6 is mapped to 6. See, it's very long. A longer method as mentioned. 7 is mapped to 2. 2 is mapped to 1. 1 is mapped to 1. 1 is mapped to 2. And finally, for our last, 8 is mapped to 1. 1 is mapped to 2. 2 is mapped to 2. And 2 is mapped to 1. This is now the result or the permutation, which is the product of the 4 different cycles. You have here 1, 2. You have 4, 7, 8. You have 2, 1. And you have here 7, 2, 8. Okay, let me rewrite all of this just for illustration. So again, this is 1 and 2, 4, 7, 8, 2 and 1, and you have 7, 2, 8, 1, and 5. So what is the shorter method here? The shorter method is simply using the given cycles. You have your 1, 2, 4, 7, 8. 7, 2, sorry, we still have 2 and 1. 2 and 1. And 7, 2, 8, 1, and 5. Now, the idea of the shorter method is just looking at the cycles and understanding that for this specific cycle here, let me use another color, black, that for this specific cycle here, we can already see the mapping of the elements. And those elements not found here are automatically, as mentioned earlier, just mapped to themselves. So we're still going to move from right to left. And of course, our permutation is still in S8. 5, 6, 7, and 8. So we're going to do it like this. Okay. Since 1 is here, let me remove this first. Okay. 1 here is mapped to 5. Okay, take note of that. But we are not yet done because we still have 3 more cycles. So 1 is mapped to 5. Going to the next cycle, we don't have 5 here. Understandably, 5 is just mapped to 5. Here, 5 is also mapped to 5. And here, 5 is also mapped to 5. That means automatically 1 is just mapped to 5. So for some cycles where the elements are specific elements that are already mapped from original element, so automatically it's being mapped to itself. How about 2? 2 is mapped to 8. When you go here, we will not be using 2 anymore because we already moved to 8. So 8 is still mapped to 8. But here, 8 is mapped to 4. And then 4 is mapped to 4 because there's no 4 here. So 4 is the last mapping. How about the 3? There's no 3, so 3 is mapped to 3. 3 is mapped to 3. 3 is mapped to 3. Of course, 3 is also mapped to 3. How about 4? 4 is mapped to 4. 4 is mapped to 4. Here, 4 is mapped to 7. Now, it's 7 now. 7 is mapped to 7. Look at the first 4 here and first 4 here. We could see they're just the same. Let's see if the rest will really give us the same results. Let's have 5. For here, 5 is mapped to 7. Okay? Now, we are now on 7. 7 is mapped to 7. And here, 7 is mapped to 8. Now, 8 is mapped to 8 here. That's it. Next, 6. There's no 6 here. 6 is mapped to 6. 6 is mapped to 6. 6 is mapped to 6. And also 6 is mapped to 6. For 7, 7 is mapped to 2. Take note, we are now on 2. 2 is mapped to 1. So from 7 to 2, 2 to 1, we are now at 1. We are no longer in 2. We are no longer in 7. We are now at 1. Again, 7 is mapped to 2. 2 is mapped to 1. 1 is mapped to 1. And then 1 is mapped to 2. Okay? And finally, 8. 8 is mapped to 1. 1. Okay, we are now on 1. 1 is mapped to 2. So we are now at 2. 2 is mapped to 2. And 2 is mapped to 1. See the two results. we have the same results using this shorter method with just an analysis, and the longer method earlier involving 4 different permutations, 1 for each cycle given. So again, it's still up to you which you will be using. Some of you might choose the longer method and it's okay. Some of you might choose the shorter method and it's good, as long as you can actually analyze it properly. Nevertheless, this is how we determine the result of the product of cycles as a permutation on the same specific set, in this case S8. Thank you very much for watching.